Lorry conflict. Okay, I got a lorry alcohol ethoxylate. Now, when I say lorry alcohol ethoxylate, this variation is lauric acid and reaction of ethylene oxide. Now, lauric lauric acid and how many ethylene oxide moles I have to take, depending on that surfactant gets prepared. Suppose if I'm using 5 moles, so what I get? Lauryl alcohol, ethoxylate 5 moles. If I get 8 moles, then it becomes lauryl alcohol, ethoxylate 8 moles. So the surfactants are always referred as lauryl alcohol, ethoxylate. This information is halfway. People will ask how many moles? 2 moles, 3 moles, 5 moles, 8 moles. So you have to always say lauryl alcohol 8 moles, lauryl alcohol ethoxylate 8 moles, lauryl alcohol 5 moles. That is lauryl alcohol ethoxylate. Clear? Somebody else is making that surfactant. He takes lauric acid, he takes ethylene oxide, which is difficult to handle. He does reaction, and you know you are a MSc chemistry student. You know the reaction takes place on the mole basis. Okay, so you get a lauric acid, you get 8 moles of ethylene oxide based on the surfactant. For this particular emulsion, we require 5 moles of ethoxylate and 8 moles of reaction. Okay, so who are my assistants? Who raised my come? You are smart boy. So what you have to make, weigh around 87 grams of this material. This is silicone oil. This is silicone oil. Okay, once you weigh, show them in the beaker. It's a transparent material. Make 87 grams.
એવી જગ્યા છે કે જ્યાં તમે લર્નિંગ માટે આવ્યા છો, બરાબર? તો અહીંયા આપણે જે પ્રોગ્રામ એરેન્જ કર્યો છે તો એમાંથી તમે કેટલું લર્નિંગ લેવો, બરાબર? તો એ લર્નિંગ માટે ઇન્ટરેક્શન જરૂરી આપણા બધા. ઇન્ટરેક્શનમાં કેવું હોય, પ્રેઝન્ટેશન ચાલે છે, બધું ચાલે છે, તો કોઈ ઇન્ટરેક્શન નથી. એનો મિનિંગ શું થાય કે ભાઈ બધાને બધી ખબર પડી ગઈ, યા તો શું છે કઈ ખબર નથી, બરાબર? તો ઇન્ટરેક્શન થશે ને તો શું છે, ક્વેશ્ચન તમારા મનમાં જે રાઈઝ થાય એ તમે અહીંયા આગળ રેસ કરીને પૂછી શકો. ઓકે, હવે આપણે હમણાં જે શું બનાવીએ છીએ એક ઇમલ્સન. ઇમલ્સનની કોઈ ડેફિનેશન ખ્યાલ છે કોઈ? ઇમલ્સન કોને કહેવાય?
So I am mixing these three products, silicone oil and two surfactants. Okay.
ખ્યાલ છે ઇમલ્સન એટલે શું? આપણી પાસે ઓઇલ હોય, તેલ ઘરમાં હોય, બધા કોઈ બી ટાઈપનું ઓઇલ લઈ લો, એને તમે પાણીની અંદર નાખો તો શું થાય? શું થાય?
Invisible. Unvisible. Unvisible.
એને હલાવો, સ્ટરિંગ કરો,
None.
નહીં થશે.
Invisible.
તો એને મિક્સ કરવા માટે આપણે અંદર એક કોઈ એડિટિવ સર્ફેક્ટન્ટ નાખવો પડે જે એ બંનેને
Mix કરી શકે.
એ સર્ફેક્ટન્ટ છે ઇમલ્સિફાયર. ઓઇલને ઇમલ્સિફાય કરવા માટે અંદર એડિટિવ. તો હમણાં આપણે પહેલા શું લીધું? 87 ગ્રામ ઓઇલ, બરાબર છે. પછી એની અંદર શું નાખ્યા? સર્ફેક્ટન્ટ, બરાબર. એ શું છે? અંદર મિક્સ થયા. હવે જ્યારે એની અંદર પાણી એડ કરીશું તો પાણીની અંદર ઓઇલ મિક્સ થશે. ઓકે. અને એ શું છે? બે સ્ટેબલ એક જે બનશે એને કહેવાશે ઇમલ્સન. મતલબ ઓઇલ ઇન વોટર. ઇટ ઇઝ કોલ્ડ ઇમલ્સન. ઓકે. તો બધા ક્વેશ્ચન પૂછો કે ભાઈ શું એમણે પહેલેથી જ્યારે આપણે સિલિકોન સોફ્ટનર ચાલુ કર્યા થિયરી ત્યારે અમને બતાવ્યું ને, બરાબર. તો એ બધા પરથી તમને ક્વેશ્ચન કે આ કેટોનિક છે તે ઇમલ્સન છે, સિલિકોન છે તે ઇમલ્સન છે, આ ટાઈપના ક્વેશ્ચન તમે જનરેટ. જેથી શું છે? તમને અંદરથી ઇન્ટરેસ્ટ જાગે. ઇન્ટરેસ્ટ કોને હોય? જેને લર્નિંગ કરવું હોય. ઓકે. તો પૂછતા રહ્યો બધું.
ઓઇલની ઇમલ્સિફિકેશન કરીને એટલે વોટર સોલ્યુબલ થઈ જશે.
નહીં, સ્ટેબલ રહેશે. વોટર એન્ડ
ઓઇલ બીજું
વોટર બ્રેકિંગ વોટર સોલ્યુબલ.
ઓઇલ બીજું ઇમલ્સિફાયર મિક્સ કરી દીધું એટલે
Okay. What I did, I took a silicone oil, I added 14 grams of lauryl alcohol ethoxylate, 5 moles. I added lauryl ethoxylate, 5 moles. Okay. Now I'm mixing it. Because of the study, it will become slightly easy. And I'll show you the viscosity. Now next I'm adding another amount of water, and you will find out it is forming a jelly-like a structure. Okay. I'll show you the initial viscosity, and afterwards you see how the viscosity is increasing. Can you see? Meanwhile, we will prepare for the softener while we are mixing it. So while the silicon softener is being prepared here, we utilize that time for making a cationic softener, right? Now what is the cationic softener I told you? You get a cationic softener which is available in the market. They are dissolving into the water along with surfactant. Okay, so we are making a solution. So what I am getting is we are making water first, then I will be dissolving a product called Texof CWS flakes. The flakes are like this. Can you see this? Now this will not dissolve at its own at room temperature. So that's why there is a heating hot plate here. I have to raise the temperature for the melting point of this material. Then it will dissolve into water. So I am weighing the part of the water. Then when I bring it to 65 degrees centigrade, I will add this particular weight amount of into this and make the solution into this. Okay. To dissolve that, I have got surfactant also because it will not form a stable formulation. I have to dissolve cationic surfactant, which is this is the cationic surfactant. Dissolve into water at high 60 degrees centigrade along with the surfactant. The surfactant I am having, which is lauryl alcohol ethoxylate 8, which is also used in silicone. Got my point? So I'm for a cationic softener, I'm heating water. Okay. So let it heat at a 60 degrees, 65 degrees centigrade. Reason, this will not dissolve at room temperature. Okay. Now coming back to again silicon softener. So how much water I have to add? Let us go back to silicon softener. 28. Okay. Weigh this 28 ml of water. 28 gram of water. 28. But can you see the viscosity? Can you see? Okay. Now I am adding water. Add water. We have a reinforced. See, are they water? So you see, it is thickening now. Okay? So mix it. Mix it for 2 minutes. So I have weighed 50 gram of a softener. Okay, I can make a solution here. Now I cannot add right now because temperature is just 45. So I have to wait till it forms a reasonable or high temperature. But meanwhile, I can weigh coming back to silicon softener. Okay. Can you see this? The interaction between silicone oil, surfactant and water. Okay. Now this cannot be handled, so I have to add additional water. Okay. So going back to my formulation again. So so I hope we can keep a track of both X and what is happening. So now the temperature is still it is 45 or so. So the next part in the silicone softener, I have to add additional water of 75 grams. Okay. So I have to dissolve under ice. So next part into the silicone softener is that it will become a solution now. But you need to have some thickening. You know, when you cannot apply a water-like material on the fabric, so you need some sort of viscosity from the material to pick up from that. Because whatever the damage you want to put on the fabric, it has to have some pickup. No, otherwise multiple times fabric has to move from the bar. So it has to pass in once. So you need a thickener. So we are having a thickener called alcohol, which I am adding here. So I have a pair of 120 gram of thickener. Okay. So our silicon softener is getting ready. Next moment it will be ready. So I'm just waiting for this. So we are close to 60 almost. In catalytic softener, what are the key components? You have got water, you have got a catalytic softener, which is right here. You have got a lauryl ethoxylate 8 moles. I have already made. One, it has to have what it does, what this surfactant does. It facilitates the surface tension which is having on. This is solid, no, it has to dissolve. So it will facilitate the surface tension between water and this. If it is surface tension, that's facilitated, it will not dissolve fast. It will take a lot of time. So I am adding surfactant. going by thermometer, it's like this. So I got a water, I got a surfactant. So I got a solution of surfactant in water. Now this is ready to take the cationic softener. Okay. Now it will start dissolving. Finished? So our cationic silicon softener is ready. Our cationic softener is getting ready. We are halfway. Now we'll switch over to simultaneously on a water crystalline nature. Okay. Now we are doing many experiments simultaneously. Who is having good handwriting? My handwriting is not good. Anybody is here who is having good handwriting? Come forward. Whose handwriting is good? Nobody is here. Can you take my bag? I will take my marker. So what I'm doing, I got water, I got a surfactant, the temperature is more than 65, I am adding cationic softener mix. So I am making a dissolution of all cationic softener. You require temperature, that's why I am trying to maintain the just solve it. Give this one. One side, silicon softener. GPL, maybe 10 GPL, 5, 15 GPL, 20 GPL, as per the requirement, and we will make the solution of this and apply on the this particular untreated cloth. We compare with untreated cloth and this one, and then we test on the hand filling after ironing. Why we are ironing it? Because we don't have any other method of straightener to remove the moisture and this one. So just we are why industry nobody uses iron, but here it says to make you understand how to use this practical solution. So this is one softener is ready. Okay. Now we are so in water repellent, what I am doing, I have a ready material which is a silicone softener or silicone compound which is called as the Selgard F601. So I have taken 25 grams, I have taken 250 grams of water and just mixing it. It is water soluble material. Okay. So this is water, 250 grams. So I am adding 25 grams of so this is Selgard F06 water repellent silicone material. Not my point. I am adding water. I am adding this. Why is that doing great job supporting me? Unfortunately, I don't have any lady students supporting. What is the problem? Why is that going ahead of you? Please. So now you should be coming ahead and support me. So this is your water repellent material is ready for application on the fabric. Right? This is ready, silicone softener is ready. Okay? Now we will go for the what is next? What is next session? What we studied? You have got a silicone softener, you have got a catalytic ion, catalytic softener is getting ready. This is water repellent. Next, what we studied? Yes, you are right. Come here. Correct. Come here. Very good. Attentive man. So it's a very simple thing. I have to make a so my catalytic softener is ready. So can you see this? Can you see the uniform paste as formed? This is a concentrated solution. It will become, after cooling, it will become a sort of paste. Okay?
Supporting.
So don't touch it. It's hot. So my catalytic softener is ready. I'm handling very roughly. Okay, now you said no. So we have to make a 20 GPL sample of Lagroma. We have got Lagroma jasmine, we have got Lagroma peppermint, we have got Lagroma lime. So what do you like? Lemon. Okay, I'll give you very good fragrance. Take this. Lagroma. So what is this? What was the word for this? Loudly. What is? It's not only fragrance. It's not only fragrance.
Chemistry.
What is that? What I said again and again. Can I get fragrance and put into water and apply on fabric? Like a spray? No. What it is? Correct. Say it again.
Encapsulated fragrance.
The fragrance is there, which is encapsulated. This is the dispersion. So we get a small spheres into this, in water, in which the fragrance is encapsulated, trapped. Okay? So what we'll do? We'll make a 20 GPL dispersion of this. It cannot be solution because it is not water soluble. What is 20 GPL? How to proceed? Now my friend is making 20 GPL. What I am to do? What I am supposed to do? 20 gram in? No, I don't have beaker of 100 liter. So what I should be doing? So now 100 ml will be too small. No, this much should be there. So many boys are there, they will not be able to do it. So we make a solution of a 500 ml. Okay, this is a. So let us calculate for the 500 ml. 10 ml. Correct. Can you hear from me? Yes. I want such type of ones. So 20 GPL means 20 grams in liter. So same proportion, what is doing? 10 gram in 500 ml is 10 GPL, 20 GPL only. Is this clear?
Yes, sir.
I have read last bench. You got my point? For making 20 GPL, I need 1 liter. I don't have 1 liter. Okay. So I am making this conversion into half. So 20 in 1 liter means 10 gram in 500 ml. Clear? Make a 500 ml water, put 10 gram. This one. Okay. Diligent voice. Okay. Now very simple scouring agent. Now I got a formulation. What it consists? Doryl ethyl ethoxylate 8 moles, 20 grams. I got a butyl cellosol solvent. Butyl cellosol is a solvent. It is a water soluble solvent. Then I got a monopropylene glycol, which is called in industry MPG. MPG is monopropylene glycol, which facilitated, which is very small, 0.5 gram. And then I got water. So I got water around 64%. I got MPG 0.25%, just facilitate the mixing. I got butyl cellosol around 15.5, which is solvent, which is water soluble solvent. And I got a lauryl alcohol ethoxylate, which is a surfactant around 20 grams. So in my formulation, I got a surfactant, I got a solvent, I got a monopropylene glycol and a water. So ethyl butyl cellosol will dissolve material which is not soluble in water. We studied in scouring. There are so many material. There could be water soluble, there could be oil soluble, or there could be which is not water soluble. To make it water soluble, you need butyl cellosol. To facilitate the dissolution, you need a surfactant which is lauryl alcohol ethoxylate 8 moles. Okay, we'll start now. You read this? Can you write this? Right here. Perfume finish. So your silica softener is ready, your cationic softener, so cationic softener very mixed. Yes, finish it. Just like that. Now can you write the cationic softener? Now it is already. So your water repellent agent is ready. Your perfume finish is ready. Your silicone is ready. Now, 60 grams of water. Then add this. This one, you go with. So this is your cationic softener. Can you apply on the fabric? Can you apply this? No. Huh? So this is a ready for industry. Now what industry does? They make a solution. Maybe 5 GPL, 10 GPL, 20 GPL, 30 GPL, whatever. Your cationic softener. 4 agents are ready. Now we'll start application. Meanwhile we are making water. So, okay. We can sell the salt. So we are making scouring agent. What is in scouring agent? You have got water, you have got L'Oreal alcohol ethoxylate, you have got a butyl you have got a monoprivileged line. So this addition is going on. Are you following? Now whatever the theory we have discussed, we are preparing now, and then we will do the application. Now scouring agent is also getting ready. So let us first test this scouring agent. I have got this type of pieces. Okay. You can test this. What is this? This is
थोड़ा कागज ऊपर
So this is called as a gray fabric. Gray fabric. This is, you need to clean it. You need to remove the unwanted material into this because you want to give surface treatment for that. There is a wax, there is a lot of dirt and dust what we have seen, right? This is a plain water and you are trying to remove it and putting it here. Yeah. Are you seeing this? It is not going. Come here, please. Come here, come here. See. Come, come. It is not getting there. What will I do? So I have to get from here. What look at here.
Now see.
वाटर
It is not even talking. No. So this is the gray fabric, that is untreated fabric. I am putting into this. This is not getting wet. Now I need to do the scouring. So I got a solution. So I got a scouring agent, which is like prepared in front of you only. I am putting it here. How many seconds? Not even 5 seconds, not even 2 seconds, 1 second, not even 1 minute. Can you see? You can do it yourself. This is not a magic. This is your science. Because this solution has a wettability to improve the wettability. What is there? There is a brittle silicon, there is a surface active agent, there is a water, there is a monoclonal glycol, potassium carbonate. So this will help you to remove all these things. So to remove this, first up it has to get wet. Now you keep for 5 days, it will not get wet. Clear? We said this is hydrophobic method. This is
પહેલી વાર સાંભળ્યું દ્રાવક ચાહક દ્રાવક નિંદક ખ્યાલ આવી ગયો ગુજરાતી હા
And why it is hydrophobic? Great. Why?
maybe it has the impurity
Like what is
dust any pollutant dust or any wax
Yeah, wax. Wax is water soluble or insoluble?
insoluble
So this grey fabric is contains some impurity which are not water soluble.
Soluble.
So this is hydrophobic.
normal water. What is this? Covering agent. What it contains? Water, hydrogen, surfactant, and monochloride. So it is covering.
1, 2, 3.
So whatever I said, I have proved it, right? So one experiment behind, okay? You get it? So this is untreated fabric. This is untreated cotton fabric. Touch it. Same category. So I have a fabric which is untreated. I have a fabric again untreated. I will put into bath. I will remove water and then I will test. What we will test is first silicone fabric, silicone softener. Yes. 20 grams. So he has prepared 20 GPL of silicone bath. 20 GPL silicone. I'm not a magician. Huh? Your colleague only has prepared this. He has put out this one. So I have an untreated fabric. So I'll take treated, untreated. Put into this. Keep for 5 minutes. Not instant. Okay. We keep it for 5 minutes. Okay. So this is our restaurant so that I can remember. Or rather you can write one more silicone softener. Silicone softener. Okay. Let us go for this is the concentrated. This is now this is diluted. And now same you want bigger?
પેલા બ્રેકર છે ને એની પાછળ પાછળ આઈકા છે
So why I'm using this iron? Come forward. Come forward. Last bencher, ladies, please come forward. Come.
આવને એક અસ્ત્રી કરવાની તૈયાર છે તમે કહો એટલે
See, I don't remove the water from the fabric. This is this one. So silicon softener, cationic softener. Okay. So cationic, we have a cationic softener, concentrated. I have prepared diluted, say 20 GPL. Okay. I made a bath fluid which is can be directly used in industry. So I am taking this crop, put into this. Give for some time, maybe 10 minutes. Okay. So I have a perfume finish. Okay. Right. Fragrance finish or perfume finish, untreated fabric, I am putting into this. So we need to give some time to deposit onto this, right? So how they must be doing in this? They must be having such type of beaker, 100 times bigger than beaker like this. What could be done? How they must be doing, say 1 kilometer fabric. How they must be doing it? Can you imagine? I show you the padding machine. It's a continuous long, almost maybe 100 feet, 100 meter long. There is a bath, such a bath, cloth is passing through us. So we have a key fabric being treated into this one. Okay? Silicone softener being treated, cationic softener is being treated, and perfume is being treated. You have seen a scouring agent. You want finished, right? No. Something? In the same way, disinfectant finish. I have a ready disinfectant which is called as a Brintashil AMBD. This is a direct agent which we manufacture. You have to make a solution of this. You take a material from us, make a solution of it, and similar such type of bath you can prepare and dip the fabric and dry it. Now, as I mentioned to you in the class, that you cannot measure with or observe if this is disinfected or not. How will you do it? How will you do it? How to ensure that the cloth which is made is disinfectant? What I said? Yes. How to find out that? I said something. You can't do it in a normal way in the industry. It has to go to the third party laboratory, which is a biological laboratory, which decides how much disinfectant it can be with the known viruses and bacteria. So there is a process called as a log reduction, and they will tell you that how much it can reduce, how much disinfecting property it is having. We can't do it in a laboratory. You can do it, we provide all the equipment and trained staff, but we go to outside field. So this is a very simple method you cannot have. You understood this particular thing? Now let us start testing. Silicon softener. Okay. First piece is remove maximum amount of water. Okay. So I am putting it here. I cannot directly put this iron, so I put onto this so that I can remove water. What process I am doing? You can say curing, you can say drying. I am exactly removing water from the two fibers, water and removing.
બી કરો છો.
Come forward. Ladies at the center, come forward.
આવી જાઓ ફટાફટ 2-4-5 જણ આવી
This is untreated. Tell me the difference.
લઈ જા બધાને બતાવો કયું સારું છે.
Or it is unmarked, but you can find out which one is what. One is untreated, one is treated.
પાછળ જતા સુધીમાં ખબર નથી પડતી કયું કામ તમારે કહેવાનું હવે પકડી તો ખ્યાલ આવવો જોઈએ ને પ્રોસેસ જે પ્રોસેસ વાળું છે તે પહેલું મોકલજો છેલ્લેથી
કયું ગમે તમને.
આ વિચ વન યુ લાઈક તમને કયું ગમે
It is a bill.
What is the difference? Have you tested? What is the difference you are finding? Tell me.
One is a little bit rough and the second one is very smooth as compared to this.
So, the signal software is active. Boys at the back, do you understand what I'm saying? Yes. Ladies, you observe the difference between two? So, do you believe what I was saying in the class and what I am doing now? I done everything in front of you. No magic, only chemical reactions. So now we are treating the fabric with a cationic softener. And apart from the what do you call the softness, we see the water absorbency also. Let us see. Sit okay. And you treated, untreated with the cationic softener. Now tell me. Unbiased here. You don't know what is what. Smooth feel, hand feel, softness, easy to iron.
બધાને પોથમાં સમજવી
મેં નહીં કીધું પછી કે આ વધારે ખબર લાગે ચાલુ
So especially if you would look at cotton t-shirts, find out that finish. This is nothing but softness only. You have fabrics?
कपड़ा बहुत
These are different fabrics which are prepared and prepared.
આનું કન્ટેનનું કે આનું ચાદર
ના ના આ નીડ્સ બધા ગાર્મેન્ટ્સ
પ્રિન્ટિંગ બી આ લોકો જ કરે કે તમારા
ના એ બધા પ્રોસેસ અમારે કોઈ કન્સ્ટ્રક્શન ખરું ને ફેબ્રિક કન્સ્ટ્રક્શન સપોઝ આ છે આ કોટન છે બરાબર આ ટેરી ટી શર્ટ એ નીડ્સ છે આને વોવન કહેવાય અને નીડ્સ કહેવાય આખું એનું જે વિવિંગ છે ને એ જ અલગ છે આનું મશીન ગોળ આવે પેલાનું મશીન પ્લેન આવે એટલે આખું ટાંકો જોઈએ ને આપણે એવું આવે અને આનું સર્ક્યુલર આવે ગોળ આવે આ કપડું ગોળ બને મશીનથી ગોળ આવે અને એ નીડ્સ કહેવાય હા
સર અમને
હા એ સુરત આવવું પડે સુરત બધું છે
હમણાં તમને સ્પેક્ટ્રમ
અચ્છા ડાઈઝમાં સ્પેક્ટ્રમ
આગળ અમે
So very simple. I told you.
નિર્મલભાઈ વારમાં સુમિત્રા ડાઈંગમાં
હા
તમે જે કીધું ડેનિંગમાં આ વિવિંગ વાળું આખું બનાવ્યું.
અચ્છા
આમાં બી ઉપરના માળે ત્રીજા માળે કેમ છે જલસામાં 2 વર્ષ થઈ ગયા.
આ બધું ગ્રે ફેબ્રિક છે ને રો ફોર્મમાં થાય છે પહેલાં જે ગ્રે કીધું ને એમને ગ્રે બધું ઇમ્પ્યુરિટી હોય એમાં કોટન્સની અંદર બધી ઇમ્પ્યુરિટી આવે વેક્સ પણ જે સિન્થેટિક છે ને તે કેમિકલથી બને યાન એની અંદર કશું નહીં આવે એ બધું રીજનરેટેડ કહેવાય અને એમાં પોલિએસ્ટર આવે નાયલોન આવે
બરાબર સિન્થેટિક ફાઈબર્સ બધા
પણ એને વિવિંગ કરવું હોય અંદર મશીનમાં તો એની ઉપર ઓઇલ લગાડવું તો એ એડ થાય એને પછી ફેબ્રિક બની જાય પછી એને કાઢવાનું એના માટે આ સર્ફેક્ટનથી ક્લીન થાય ઓઇલ્સ બધા એટલે પાછું એ એબ્સોર્બન થાય હાઇડ્રોફિલિક પછી એના પર કલર ચડે પછી એના પર આવું પ્રિન્ટિંગ થાય ત્યાં સુધી ઉપર કંઈ પણ કરો કંઈ નહીં થાય
You have to compromise. Software and they are two opposite products. So silicon is what you can modify this, you can manufacture the same. Any other different see fabrics in front of you. And we can so this all makes auxiliary, whatever the name of the product is, auxiliary again. What do you manufacture? Textile auxiliaries. What do you do? Treating of the fabric, that is textile processing. And finally what you get in the shop are treated fabrics. Otherwise, normal fabric you cannot wear. You make it wear to make it dye properly. So there are polyester fibers, there are nylon fibers, there are cotton fibers. Other than that, you get the football players. You take the jersey, it's a nylon jersey. It becomes so rare after loading the house. What is it? This is because where the people absorb moisture.
આ જો આ ગ્રે અને આ પ્રોસેસ થાય આ જ છે આપણે
અચ્છા આપણા પ્રોસેસ થયા પછી આવું થઈ ગયું એમ અચ્છા બરાબર
આના પર કંઈ
આમાં પાણી મૂકો તો જશે જ નહીં અંદર છોકરાઓ કહો કે આ થોડા સેમ્પલ ને આ બધું મૂકી જાઓ અમે પછી લેબમાં અહીંયા પેપર રીતે કરીશું આ પ્યોર કોટન છે સેમ્પલ આપી જાઓ 100% કોટન અમે લેબમાં છે ને અમારી રીતે એક દિવસ રાખીશું બરાબર આમાં કદાચ નહીં દેખાતું હોય અંદર એની કપાસ આવે ને કપાસ એની સીડ્સ પણ આવે કાળા આની અંદર નથી પણ એને કિટીસ કહે કિટીસ એ અંદર વ્યૂમાં આવી જાય એને માટે પ્રોસેસ છે હાઇડ્રોજન પેરોક્સાઇડ આવે નીચે ઓક્સિડાઇઝ થાય પછી વ્હાઇટ થાય આ વ્હાઇટ આમાં ઓક્સિડાઇઝ